All right, here is just a brief review for solving some different types of equations in case your brain got a little bit rusty on your algebra. First of all, if you do not have something to write with and a piece of paper, I would suggest you pause the video and go get one because you'll want to write this down, try solving some of these yourself as well, just to make sure you know what you're doing. So if you don't have those, please pause it, go get that, and then come back. All right, so we're just going to go through just a couple quick examples. Most people remember how to solve a very basic equation, I'm sure. So a basic two-step equation. For example, we might have 12x minus 5 equals 43. So if this is our equation, this is the type that most people tend to remember, but if you don't, that's okay. Remember that when we are solving equations, we're using inverse or opposite operations, and our objective is to get the x all by itself. So here's our x, here's who we want to get by itself. Over on the same side of the equation, we've got two things with the x. We've got one that's kind of further away, so if we think of this as the couch, the x is sitting further away from this -5 than it is to the 12. So generally when you're sitting closer to one person than another, you like the other person a little bit less. So we want to move this -5 first. So get rid of the stuff that's further away first by using the opposite operation. The opposite of subtraction is addition, of course. So we're going to add 5 here to both sides. So when we do that, we can add straight down our columns. We've got 12x here, the -5 and the 5 cancel out. That's the whole point of opposite operations. And then 43 plus 5 gives us 48. So now that's our one step. This is a two-step equation because we still have this 12 here. The x might like the 12 a little bit better, but it still needs to get by itself. So we need to get rid of this 12 too. Remember that when no operation is written between a number and a variable, that it's understood to be multiplication. So this is 12 times x. To undo multiplication, we use the opposite operation, which is division. So we're going to divide both sides by 12 here. These will cancel. 48 divided by 12 is 4. Now, remember that when you solve an equation, just because you got x equals should not mean that you're done. When you are working even computational problems, and certainly even more important when we're problem solving with real life situations, you need to make sure your answer makes sense. So look at your 4, look at the original. If I put 4 in for x, 12 times 4 is 48. Minus 5 is 43. So I'm not just guessing, I know that 4 is my correct answer. So there's a basic two-step. Now, I'm going to look at something relatively simple. You're not going to see one like this in the homework, but I do want, you'll see ones that need this concept in the homework that are a little bit more complicated. But I just want to remind you of what to do when you have a fraction next to your variable. So let's say that you had 2/3 y equals, I don't know, 7. Here, most people see, oh, I need to get rid of the 2/3, but for some reason they forget how to get rid of a fraction. It is very important to this class that you know to get rid of fractions that you are going to multiply by the reciprocal. And I'm going to put here that this is kind of a single fraction because I don't have fractions everywhere, and I don't have fractions on both sides. So to get rid of this, I'm going to multiply by the reciprocal. Remember that reciprocal means you flip the numerator and denominator. So the reciprocal of 2/3 is 3/2. So to solve here, I'm going to multiply both sides by 3/2. When I do that, these cancel. My variable y in this case is alone. Over on the right-hand side, another very important basic math thing that you need to know back from elementary school without the help of your calculator is how to multiply fractions times each other. When we multiply fractions, it's numerator times numerator, denominator times denominator. So here, since this was no denominator, it's understood that the denominator is 1. So when I go to multiply 7 times 3/2, I do top times top, numerator times numerator, which is 21, and then bottom times bottom, 1 times 2 is 2. Now, unless there is already a decimal in the problem, or unless it's a real life situation, all of your answers in Algebra 2 should be in simplest fraction form, improper fraction form. 21/2 does not reduce. Do not write it as a decimal because there was no decimal in the original and it's not a real life problem. So leave it just like that. So while we are on the subject of fractions, let's look at one where we have lots of fractions. And most of these probably aren't going to come out as nice whole numbers, and that's okay, because in real life, things don't come out as nice whole numbers. So let's say that I have 2/5 d minus 1/3 equals, let's go with 30, and we'll do 17. Okay, so 2/5 d minus 1/3 equals 17/30. I think we can see the distinction between the example before and this one right here. We've got a lot more stuff going on. So first of all, this resembles a two-step equation, and you can solve it like a two-step equation. That is absolutely not wrong. There are multiple choices here for how to solve this. And in fact, there's more than two. I'm going to show you 2 ways to solve this, but there are more than that. So choice 1 is that you treat it just like a two-step equation. So that means that my first step, and I'm going to recopy the, oops, forgot my d, 2/5 d minus 1/3 equals 17/30. So choice 1 means that my first instinct would be to add 1/3 to both sides because I'm working to try to get d by itself. So that would give me 2/5 d on the left, and on the right side I've got 17/30 plus 1/3. Now, many times in this class you're going to be allowed to use your calculator, but there will be some times where you are not. So it's really important that you know basic math. To add fractions, they have to have a common denominator. So I can't just add these and say 18/33. That doesn't work like multiplication. I need to convert my smaller denominator here, which is 3, to a number that is going to match. So because 30 is a multiple of 3, this one's pretty easy, and I can just multiply the bottom by 10 and the top by 10 and have an equivalent fraction with the same denominator as the one up here. So now that they have the same denominator, when you add fractions, you add the top, so 17 plus 10 is 27, and the bottom stays the same. Notice that that's different than multiplication, where you do top times top, bottom times bottom. Here, you do top plus top, but the bottom stays the same. so 30. And then our second step would be to use what we did in the second example and to multiply by the reciprocal on both sides. So multiply both sides by 5 over 2, cancel this. You have a choice here. If you don't have a calculator, you can either do top times top, bottom times bottom, and then reduce. I personally, when you first learned to multiply fractions, you learned that you could cross reduce because 5 goes into 30 6 even times. So that's what I would probably do first. And then that gives me 27 times 1 is 27, 6 times 2 is 12. 27 and 12 are still both divisible by 3, so I would do that as well. So that gives me 9 and 4 for my D. So that's option 1, solve it like a two-step and use the single fraction rule. The second choice that you learned in algebra is to multiply by the least common denominator. So here when we added, we had to find a common denominator anyway. So that's why I sort of prefer choice 2, because I think it's probably a little faster. But again, there's nothing wrong with doing things the long way, especially if it makes sense to you. So choice 2 here, multiply by the LCD. Now before I had only found the LCD between thirds and 30ths. So I need to look at the 5 and make sure that 30 would still work. It's only going to work if 5 goes into 30 an even number of times, which it does. 5 goes into 36 times. So the second way we can do this is to multiply the entire equation by that LCD. Because when I do that, I can cross reduce here. 5 goes into 36 times, and 6 times 2 is 12. So that gives me 12D. Then 30 times negative 1/3. That one probably most people can do in your head. But if you can't, you can say, how many times does 3 go into 30 and reduce it like I did before. But 1/3 of 30 is 10, so I've got a minus 10 here since this was a minus sign. 30 over 1 times 17 over 30, the 30s will just cancel. So I've got 17, and now it's a two-step without fractions. So notice that I end up with the exact same answer of D being 9 over 4. All right, last thing that I want to talk about is when you have to solve some sort of formula and you're not coming up with a numerical answer. So let's just take a formula that I hope most of you know, and that's the formula for area of a triangle. So area equals 1/2 base times height is the formula. If I am told, let's say, to solve for H, because let's say that I'm trying to find H when I know the area and the base. It might be easier to solve the formula for H first and then plug in all the different values instead of re-solving a more complicated equation every single time. So if I have a formula and I'm told to solve for a particular variable, I'm still going to use my opposite operations. So if I want to get H alone, I need to get rid of this 1/2. So we talked about in the second example, you get rid of fractions by multiplying by the reciprocal. The reciprocal here of 1/2 is 2 over 1. So I multiply by 2 over 1 on both sides. That gives me 2a on the left. The 1/2 and the 2 over 1 cancel, so I've got BH on the right side. Again, I'm trying to solve for H, which means I now need to get rid of B. Remember, when no operation is written, it's understood to be multiplication. So I'm going to undo that multiply by B by dividing by B. Now, here's where people sometimes get confused. I'm not really sure why. Because you have division, there's nothing else you can do here. these are letters and they're not the same letter. We can't reduce that, so that's as far as it goes. So my answer here would be H equals 2 times A over B. All right, hope that helps you refresh your memory for solving different types of equations. Have a great night.